All right, welcome back to the Explainer. Today we are tackling the absolute fundamental starting point of physical geography. If you've been looking for a clear, no-nonsense way to understand the origin of literally everything around us, well, you're in the exact right place. We're going to deconstruct the Big Bang Theory, taking you from a tiny, microscopic point in space all the way to the massive, expanding universe we observe today. So get ready to focus in, because by the end of this explainer, you'll be able to break down the origin of the universe way better than any textbook.
Okay, I want you to imagine just for a second that everything you've ever known, your house, the towering Himalayas, the massive Pacific Ocean, heck, even the device you're watching this on right now, imagine all of it squeezed into a space smaller than the tip of a needle. I know, right? It sounds completely like science fiction, but this isn't just some wild theory. It's literally the bedrock of our understanding. To really grasp the sheer scale of the universe, we first have to wrap our minds around it being compressed into absolute nothingness.
So let's dive into this. Here's our roadmap for today's explainer. We'll hit the ultimate singularity, run through the Big Bang timeline, check out the evidence for an expanding universe, look at some competing origin theories, and finally, tie it all back to why this is so relevant for your UPSC exams.
Starting off with Section 1, the ultimate singularity. For this first step, we need to rewind the clock a long way, about 13.8 billion years to be exact. At this specific moment in time, all the matter and energy in the universe simply did not exist in the way we see it now. Instead, everything existed as a single, solitary singularity. It's kind of hard to picture, I know, but before the Big Bang, the whole shebang was contained right here in this singularity.
Now, what's really interesting about this is how perfectly it packages the facts you need. If you're writing a mains answer, you absolutely need to commit these three keywords to memory. The singularity was a point with infinite temperature, infinite density, and microscopic size, which effectively means zero volume. We're talking unimaginably small and infinitely hot. These are the exact phrases your examiners are looking for sure.
Moving right along to Section 2, the Big Bang timeline.
So, 13.8 billion years ago, the singularity didn't just explode in space. Explosion is actually a bit of a misnomer. It was really a violent, rapid expansion of space itself. And after that initial bang, things moved incredibly fast. Within just the first 3 minutes, the very first atoms started to form. Just think about that for a second. The fundamental building blocks of our entire reality were decided in less time than it takes to boil an egg. Crazy, right? But early on, the universe was totally opaque. Think of it like a thick, super hot soup of particles. It wasn't until 300,000 years later that things cooled down enough for the universe to actually become transparent.
And that cooling process brings us right to this specific number, 4,500 Kelvin. At that 300,000-year mark, the temperature of that opaque, hot soup dropped to exactly 4,500 K. Why does that matter? Well, this temperature drop is a massive milestone because it finally allowed light to break through that thick atomic fog and travel freely across space. This is literally the exact moment the universe as we know it became visible.
Okay, on to Section 3, evidence for the expanding universe.
To really grasp the physical evidence of this expansion, let's use a classic analogy. I want you to imagine blowing up a balloon. If you take a marker, draw a few dots on that balloon, and then start inflating it, what happens? The dots themselves stay the exact same size, but the physical space between them grows as the rubber stretches out. And here's a crucial exam tip for you. When we say the universe is expanding, the galaxies themselves, our little dots, are not expanding. It's the space between the galaxies that is increasing.
And this elegant little balloon analogy connects perfectly to what Edwin Hubble discovered back in 1929. He observed a phenomenon called redshift. By looking at the light coming from distant galaxies, Hubble noticed that these galaxies are actively moving away from each other. The space between them is stretching out, just like the rubber of our balloon. This observation was the absolute smoking gun. It proved that the universe isn't static. It is still expanding right now, today.
Next up, Section 4, competing origin theories.
Let's neutrally contrast the two historical heavyweights here. On one side, you've got the Big Bang Theory, or the expanding universe hypothesis, which states the universe is constantly growing and changing from that single point. But on the other side, we have Hoyle's steady-state theory. Hoyle suggested that the universe basically looks the exact same at all times. No beginning, no end, and new matter is continuously created to keep the density constant as it expands. Now, while the Big Bang has the most backing today due to overwhelming evidence like redshift, a smart student needs to show they know their history. Mentioning the steady-state theory in an exam gives you a complete, well-rounded perspective of the source material.
Finally, Section 5, UPSC Exam Relevance. Let's anchor this back down to Earth.
So, you might be wondering, why does a geography student even need to know this? What does the early universe have to do with the mountains and oceans we study today? Well, it's all about this vital chain of causality. The Big Bang led to the expansion. As the universe expanded, it cooled down, and as it cooled, gravity was finally able to take over, clumping massive clouds of gas and dust together. This clumping directly sets the stage for the nebular hypothesis, which is the specific process explaining how our very own solar system, and eventually the Earth, formed from a spinning cloud of gas. You see, the Big Bang wasn't just the start of space, it was the ultimate origin story that made the Earth's geography possible in the first place.
And that brings us to the end of today's deep dive. But before you go, I've got a quick challenge for you to test your active recall. Who was the scientist that provided the observational evidence that the universe is expanding? Lock that answer in your mind. Understanding this cosmic foundation is your crucial first step. Keep that curiosity alive, because in our next explainer, we're going to take this newly formed Earth and slice it open to explore the fascinating formation of its internal layers. Thanks so much for learning with me today, and I'll see you in the next one.